Hi, everybody. Welcome to Statistics. I'm so excited to get to start another year and to get to teach you guys statistics. It's one of my favorite things to do. As in any topic, any subject, you kind of have to have some background information. So bear with us during the first couple of chapters. We'll get into the good stuff as we go, but we kind of got to have just some background, where it comes from, what it's for, how you apply it. So statistics itself is the science of conducting studies. So we actually do something, watch something. We collect, organize, summarize, analyze, and draw conclusions from data. So, I mean, it's actually a lot bigger than it sounds. A few reasons why. First of all, most professions use some sort of statistics. I mean, obviously, I'm in education. I use statistics all the time. Um, you hear it in the world every day about statistics. So you're going to need to know your vocabulary, your concepts, your applications within a work setting. There could also be research in your field. So you're going to need to potentially, right, design experiments and or use data, one or the other or both. And last but not least, the biggest thing, I think, I mean, takes a special kind of person to actually do that, use that, do the research. But for all of this, for all of us, we need to make informed decisions. There are numbers and statistics flying around out there all over the place. So you need to know how to see them, read them, ask questions, and make informed decisions. Use and understand the data that's out there. If you haven't noticed, there's a lot of people out there in the media and in different professions that are good at making the data work for them. So you need to know what's going on and where it's coming from and how you can apply it. So where do you see statistics? Everywhere. In research, in operations. If you're owning a company or managing a company, making sure that everything's good. I mean, it could be money, it could be man hours, it could be overhead costs, it could be costs of a product, all data. Quality control, if your quality control is poor, you're going to have a lot of returns or a lot of inventory unsold. Estimation, prediction. So most of those are things that go on right now. Prediction is the big one. You know, what's the probability that it's going to rain tomorrow or snow next week? That's prediction, and that's obviously a less exact science. Take a minute, watch the Moneyball trailer. I don't know if you've ever seen the movie Moneyball. It's about a professional baseball team. Brad Pitt's in it. And he was cutting edge when it came to using statistics to recruit and sign players. And then there's an article that goes around along with that. So we'll talk about those two Moneyball things. It's kind of an interesting real life application. So I can change the page. Struggling. Here we go. All right. So you've probably heard of a variable before. If you've had me for math, I know you've heard of a variable, right? A variable is an unknown when we don't know something. In statistics, a variable is a characteristic or attribute that can assume different values. That's exactly what it is in every math class. Our variable can assume different values. So we'll measure a variable. What is the height of every student in the school? For example, maybe our variable would be customer names. It could assume different values. The amount of daily sales over a summer, the favorite television programs. There's a lot of different, really anything you can use a variable for. Random variables are values that are determined by chance. So a roll of a die, lottery winner, slot machine maybe could be debated, those kinds of things. Picking a queen if you've got a deck of cards, all those things. Data itself, remember, as we're going through these, feel free to stop, pause, rewind, whatever you need to do. Listen to my words. I know that my voice is irritating, but if you listen to me talk, I often say more than just what's in the on the board. Data themselves are values, measurements, or observations, the compilation of them. So you compile your data. So all those different values that our variable could take is our data. So for example, we might have measurements like say shoe size or the number of pets or how many days a week you eat vegetables or something like that. Or that data could be observations like hair color or I don't know, eye color. Things that you observe. So you measure or you observe for some data. Data set is a collection of the data values. So the data set of all the ages of the students in our class. And just for the ELA person in me, data is actually plural. If you're talking about one piece, it's datum, which feels like a really weird word. So just thought you'd want to know that. Fun fact. So populations and sampling. This is going to be a big topic. It's going to come up a lot. So notice I've got this little diagram over here. Population is the large blue circle. Sample is the small yellow circle within it. So a population is all the subjects of interest are being studied. If I want to do a study of all East China students, my population would be all East China students. All are subjects of interest or what's being studied. Doesn't have to be people, remember. It's a weird thing, but population we always associate with people. It could be deer population in Michigan. So that would be our population. It could be humans, animals, business entities, products, whatever. So it does not have to be human beings. And a population size usually makes gathering data really difficult. If I'm going to gather my population is all people in Michigan, it could take me a long time. It could be very difficult to get in touch or get my data from every single person in the state of Michigan. So therefore, because of that time or expense or difficulty, we go to a sample. So population is everything being studied. A sample is a group of representative subjects selected from the population. Representative is a really big word in there. We want it to represent our population. So if we were doing a study and our population was all students of East China School District, and we said, okay, our sample is going to be Mrs. Nelson's 5th hour class. That may or may not be representative. So we'll talk a lot about that, and we'll talk about bias. Bias is when you do not have a good representation. So it's a non-representative results due to a poor selection. If I wanted to do in Marine City High, if I wanted to do a study about the students who drive to school, and I asked only 9th graders if they drove to school, would that be a good sample? My population is all Marine City High. My sample is the whole 9th grade class. Probably not the best representation, right? Because how many 9th graders drive? Maybe I need to do all 1st hour classes instead, because then I'd probably get a good mix, unless 12th graders don't come to school 1st hour. So, all right. So this little practice problem down here. When designing a study or doing research, would you want to study the entire population or a sample? And why? Well, here's the key word here. Would you want to study? I think that every scientist, statistician, would want to study the population. However, because of time, expense, and difficulties, you usually end up only doing, only sampling the sample. So population is the ultimate goal. And sample is typically what we have to resort to. That's why we want it to be a non-biased sample. Really important to think about that. So let's talk about two different types of statistics. So there's descriptive statistics, and then there's inferential. So descriptive statistics are collection, organization, summarization, and presentation. So I just collect the data, whatever it is, I organize it, I summarize it in some way, and I present it. Put it in a little graph or whatever I'm going to do with it. Summarize it might be writing it out, giving a presentation, those kinds of things. There are no conclusions drawn. We can't make a conclusion, an inference, or generalization. It just describes, it's descriptive statistics. So if I do a study of shoe sizes, I just show all the variation of shoe sizes of students of Marine City High. I don't draw a conclusion that like, oh, kids in Marine City have big feet. That wouldn't be appropriate. It's just descriptive. And this is, like I said, data only. That deserves a star. Data only. So for example, maybe I don't have an example in here. For example, maybe I do, maybe I'm thinking about people who wear like Fitbits or Apple Watches. Are they more active? Well, I can't draw a conclusion that they're more active or not. Let's do this. Apple Watch, Fitbit. The only thing I could do or say with Apple Watch or Fitbits is I could record the number of steps taken daily. I could present it. I could even include people who don't have an Apple Watch or a Fitbit and show how many steps they take daily. So I could just collect it and show it. That's descriptive. It describes what I'm looking for. When we want to take it a next step, that's inferential statistics. So we're generalizing from a sample to a population. I'm saying, oh, well, my first hour class, all the students with Fitbits walk more. So I'm going to say that probably all people walk more. So I use probability to draw conclusions and make inferences. Making inferences is inferential statistics. And later on this year, we're going to use hypothesis testing to evaluate claims. We're going to say, well, this is the claim they've made based on this sample. Is that a valid claim? Can we claim that Fitbit wearers walk more than other people? So really, when we say evaluate, we're looking at how confident are we about this statement that we made? So let's do a quick little run through. I think this should get to the idea if you don't already. So notice this graph that I've got is the number of children under age 18 in the US for 1950 to 2010 and projections. So on my screen, all these blue bars actually should go this far, right, based on our year. This is 1950 to 2020. This part is 2030, to 2050. So if I'm going to ask about descriptive and inferential statistics, which part is descriptive, which part is inferential? Descriptive just describes the data. It has to have already happened. So from 1950, to 2020, sorry about that, my board's going, now my board's really going crazy. From 1950 to 2020 is describing the data, maybe not even 2020 since it is 2020, you know how long it sometimes takes data to get together, but that's describing the data. The inferential part is going to be making an inference, prediction, what's happening in the future. So that would be 2030 to 2050 because because descriptive is describing what's already happened. You've collected that data. Inferential is making an inference. Oh, let's see, I'm going to skip that. I think that's in your notes. I don't think this is in your notes, but I wanted to run through really quickly and talk about these, and maybe we'll talk about these in class. Describe or determine whether descriptive or inferential statistics were used. So the average price of a 30-second ad for the Academy Awards show in a recent year was $1.9 million. If we remember that descriptive describes what we know and inferential makes an inference or a prediction, since it says in a recent year it's already happened, this has to be descriptive. B, the Department of Economic and Social Affairs predicts that the population of Mexico City, Mexico in 2030 will be 238 million people. Well, there's a big keyword in here. If they are predicting, that's a big inferential. A medical report stated that taking statins is proven to lower heart attacks, but some people are at a slightly higher risk of developing diabetes when taking statins. Well, that one's an interesting one because the proven part would be descriptive. However, some people are at a slightly higher risk. I feel like we're going to have a descriptive here because they've got to base that on science that they already know. They can't go ahead and just make something up. A survey of 2,234 people conducted by the Harris poll found that 55% of the respondents said that excessive complaining by adults was the most annoying social media habit. I might agree with them. However, this is a survey that was conducted, so they're just presenting the information. So this feels very much like descriptive. All right, so our first day of notes. Remember, they are always available. You can go back, you can double check, you can re-watch them if something didn't make sense, and have a great day.